Hello students. So in the previous video we had discussed about equations for uniformly accelerated motion, right? We had derived three equations. V is equals to V0 plus AT. This was the first equation. D, displacement is V0t plus half AT square, and the last one V square minus V0 square equals to 2AD. These are the three equations to be used when acceleration is constant, right? These were the equations for uniformly accelerated motion. So if in the question acceleration is given as constant, only then you can use these three equations. Okay, now we'll solve the questions based on this uniformly accelerated motion and how to apply the formulas in the questions, right? See the first one. Car starts from rest. So in such kind of questions, in solving such questions based on uniform accelerated motion, write the data given in the question. So you will get an idea that which formula is to be used, right? Car starts from rest. That means starts from rest. Initial velocity is 0. And yes, I explained to you about this formula. This is to be used for 0 to t seconds, and this is not for t1 to t2 seconds, right? Okay. So initial velocity is given as 0. Then it is moving with a speed of 180 km per hour in 10 seconds. Car starts from rest and accelerated uniformly. That means acceleration is constant. Okay. So car acquires a velocity of 180 km per hour in 10 seconds. So time taken by the car to get the velocity of 180 is 10 seconds. Find the distance covered by the car. That means you need to calculate d. Okay. See, we can find acceleration because we are having both the velocities and we are having the time. Okay, first of all, let us convert this into meter per second. Multiply 5 by 18. 1000 by 3600, kilometer to meter per second. So this will be 50 meter per second. Okay, fine. So what will be the acceleration? What is acceleration? Change in velocity by time. So acceleration will be 50 minus 0, 50 by time. So acceleration is 5. Clear? Clear? So we got the acceleration, which is 5. Now we can use this formula, v0t plus half at square. Time is given to you, acceleration is known, and you have been told to calculate the distance. Okay, this is displacement, but since car is moving on a straight road, so distance will be equals to displacement. v0 is 0, so this term will be 0. So this will be half. What is a? 5. What is t? 10 square. So this will be half 5 into 100. Clear? 250 meter. So this will be the answer. Clear? Okay. Fine. Let us solve the other question. Again, the other question is also based on uniformly accelerated motion. Okay. See. The second question says, body starting from rest accelerates at a constant rate a meter per second square for some time, after which it retards, that is deaccelerates at a constant rate of b to come to rest finally. If the total time elapsed is t seconds, find the maximum velocity attained by the body. See what the question says. Body is starting from rest, so v0 is 0, right? First it is accelerating at a constant rate of a. That means first the object is moving with a meter per second square. That means we can think that initially the velocity of car increases uniformly. That is why acceleration is constant. Acceleration is constant. After some time it is retarding at a rate of b. That means retardation means minus, right? Say first the car is accelerating. That means initially the velocity of car increases uniformly with an acceleration a. Then it performs retardation with b. and then finally it stops. That means the question says up to say any time t1, car is increasing its velocity uniformly. Then for time t2 it is performing retardation, and finally retardation means velocity keeps on decreasing uniformly, and finally it stops. Okay, if the total time is t, find the maximum velocity. See, we can draw this. First of all, we can draw this. We can understand the situation by drawing. See, there is a body. Initially it is at rest. Let us say it is accelerating with acceleration of a for any time t1, till time t1. That means from this point to this point, from here to here, the body is increasing its velocity uniformly, and then from time t1 to time t2, body is retarding. This portion it is performing retardation, and this portion it is performing accelerated motion. Clear? So then here finally it comes back to rest. So this velocity will be 0. So the body will have maximum velocity at this point. See, here the velocity was 0. Then it is moving with positive acceleration. It means the velocity of the body is increasing up to time t1. Then it is performing retardation. That means from time t1, the body is now moving with decreasing velocity. So the maximum velocity of the body will be here at this point, right? So let us say this velocity as Vm, and we have been told to calculate this velocity. Okay, and total time elapsed is given. So total time will be t1 plus t2. Clear? Let us divide the sum into two situations. This will be the first situation. This will be the second situation. But the question is all about constant acceleration, that is sure. First it is accelerating, then it is performing retardation. But both acceleration and retardation are given constant. That means car is moving with uniform acceleration. So we can think of those three equations to solve this question. Okay. See, up to time t1, body is accelerating. Okay. So let us make an equation of this Vm. We can use this formula V0 plus At for only this first situation here. So what will be the velocity? Vm initially is 0, acceleration is a, and it is taking a time t1. Up to time t1, the body is performing acceleration, right? Body is moving with an acceleration a. So a up till time t1. So Vm equals to a t1. So t1 will be Vm by Okay, now for the second situation, that means from t1 to t2, this will be the initial velocity of the body and the final velocity of the body will be 0. Now we just have to consider only this part, and in this part the velocity of the body is moving with maximum velocity, starting with maximum velocity, and it is ending with 0 velocity. So we can use again the same equation, V equals to V0 plus At. Now final velocity is 0 for this case. Initial velocity is Vm, acceleration is minus V, since it is performing retardation, so I am placing minus. So Vm by B will be equals to T2. Clear? Now in the question it is said that the maximum total time elapsed is t. So you have to calculate the maximum velocity, and the options are in terms of time. Okay, so then we can use this equation. Total time is t1 plus t2. So instead of t1 I can write it as Vm by A plus Vm by B. This will be equals to t. So t is equals to Vm can be taken common, 1 by A plus 1 by B, right? T is equals to Vm A plus B upon A into B. Therefore, Vm will be equals to, multiply B here, so it will be ABT upon a plus b. This will be the maximum velocity, ab upon a plus b into t. If the values are given in the question, then you can directly place this formula and you get the answer. Okay, done? Okay, let us solve other question, another one. Body is moving with uniform acceleration, okay, describes 40 meter in first 5 seconds and 65 meter in next 5 seconds. Okay, what will be the initial velocity? Fine. In this case, in the question it is not given that body is starting from rest, and actually we are being told to calculate the initial velocity only, right? So we only know that body is moving with constant acceleration. The body covers a displacement of 40 meter in first 5 seconds, okay, and 65 meter in next 5, okay. So with the help of this equation, see, the body, it covers 40 meter in first 5 seconds, and in next 5 it's covering 65 meter in next 5 seconds. So in next 5 seconds, that means this is 5, this will be 10, this is 65. Clear? You have been told to calculate the initial velocity v0. Okay. We can use the equation v0t plus half a t square. Suppose, let us say d1 is equals to v0t1 plus half a t1 square. d1 is given as 40, v0 we don't know, time is 5 plus a by 2 into 25, right? Acceleration is also unknown, initial velocity is also unknown, no problem. 5v0 plus 25a by 2. Let us name this as equation number 1, because there are two unknown in a given equation which cannot be solved out. Okay, so now in 10 seconds, total distance covered will be 105, 60 plus 40, 105, 65. So then now we will make use of other equation, v0 t2 plus half a t2 square. This will be 105 equals to v0 into 10 plus a by 2 into 10 square, that is 100. Clear? Clear? So 105 equals to 10 v0 plus 50a. This will be the second equation. Okay. Okay. So now we have been told to calculate v0. Fine. So we'll solve this equation. We'll multiply equation number 1 by 2. So it will be 80 equals to 10 v0 plus 25a, right? I have multiplied the equation 1 by 2 on both the sides. So this will be 10 v0, this will be 10 v0. Now let us say this equation has 3. This equation has 3. Now subtract 3 and 2. That means 2 equation 2 minus 3. So it will be 105 minus 80, right? 105 minus 80, it will be 25. 10 v0 minus 10 v0 cancel, 50a minus 25, so that will be 25. So got the acceleration 1 meter per second square, right? Right? Substitute in any of the equation. Let us substitute in the equation 3. So 80 equals to 10 v0 plus 25. Got it? So 80 minus 25. 10 v0, right? So this will be 55. So initial velocity will be 5.5 meter per second. Clear? Clear? Right? So these were the questions based on uniformly accelerated motion, right? Fine? Okay. Now we will solve another one. Particle starts from rest, accelerates at 2 meter per second square for 10 seconds, then goes with constant speed for 30 seconds and then retards at 4 meter per second square until it stops. What is the distance traveled by it? See, the question consists of uniform acceleration, then constant speed and then uniform retardation. Okay, so it's the mixture of uniform and non-uniform motion, right? Question is the mixture of uniform and non-uniform motion. Particle starts from rest. So initially velocity is 0. First it is performing acceleration for 10 seconds. Okay. So first the particle is moving with uniform acceleration. Then it is moving with constant speed for 30 seconds. So here acceleration is constant. Then it is moving with constant speed. Okay. And then it is again performing retardation. That means again constant acceleration. Okay. That means the question is particle first velocity increases up till 10 seconds. That means velocity increases increasing up to 10 seconds. Velocity increases uniformly up till 10 seconds. Then it will move with this constant velocity. Whatever the velocity particle has acquired at 10 seconds, with the same velocity it will be moving. Right? Okay. Up to 30 seconds. So say up to 30 seconds, 10 plus 30, so 40. This will be 40. Okay. This will be 30. So from 10 to 40, that means a span of 30 seconds. It is moving with constant speed. Here constant speed, constant speed. Here constant acceleration. And then it is again performing retardation. Fine. It's performing retardation till the particle stops. So final velocity will be 0. And we are to calculate the total distance. That means this distance, let us say it as d1, let us say this as d2 and let us say this as d3. We have been told to calculate d1, d2, d3. The question is easy, you just have to understand that here from 10 to 40 seconds, that is a time gap of 30 seconds, we cannot use 3 equations because for this case, particle is not performing uniform motion, uniform accelerated motion. Right? It is moving with constant speed. That means particle will not have acceleration from 10 to 40 seconds. Of course, here it is performing acceleration, here it is performing acceleration. Fine, see, initial velocity is given as 0, acceleration is given to, time is given, fine. So we can use the equation d1 equals to half a t1 square. Since v0 is 0, right, since v0 is 0. So this will be half 2 10 square. So this distance will be 100. Distance will be 100. This will be 100. Now it is moving with constant speed. Okay, so we don't know what is the speed of the particle here, no? So we just have to, we need to calculate the speed of the particle at 10 seconds. Okay, we can use this equation, v equals to v0 plus at. We want the velocity or we want the speed at 10 seconds. Initial velocity is 0. Okay, acceleration is 2 into 10. So velocity is 20. Right? So when particle reaches over here, velocity of the particle is 20. Now the particle is moving with constant speed, right, up to 40 seconds. That means a gap of 30 seconds. Till 30 seconds, particle is moving with constant speed of 20. So distance covered will be speed into time. You can use this equation when speed is given as constant. So speed is 20 and time is 30, no? 10 to 40 is 30. So this is 600. Clear? So this is 600. And finally, okay, when the particle reaches here, velocity will be same because it is moving with uniform velocity. Okay, now from 40 second, particle is performing retardation till it stops. It comes back to rest. Okay, so now particularly here we don't know the other time. From 40 seconds, particle has started applying brakes. That means it is moving with retardation. But you know the initial velocity, right? Your initial velocity for this portion will be 20, final is 0, and it is performing retardation with 4 meter per second square. Okay, so your acceleration is -4, your final velocity is 0, your initial velocity is 20, you want to calculate distance, then we can use the third equation, v square minus v0 square equals to 280. This is the final velocity, which is 0. Initial velocity means this velocity, 20, 2 minus 4 into d3 minus 400 equals to minus 8 d3 will be 50. Got it? So you got d1, d2, d3. So the total distance will be d1 plus d2 plus d3, 100 plus 600 plus 50. 750. Clear? So this is how we will solve the questions based on uniformly accelerated motion. But the thing to be noted is, only if in the given question acceleration is said to be uniform, you will apply these equations, right? But you need to practice this kind of sums, and in the next lecture we'll understand that acceleration due to gravity, motion under the gravity, sign convention, and the graph.